We usually navigate the world as if our eyes were simple lenses, recording a perfect, objective copy of whatever sits in front of us. In reality, your vision is full of holes. Where the optic nerve passes through the retina, you have a blind spot with zero sensors. You don't see a black void because your brain constantly fills the blanks, generating patterns to hide missing data. This editing process happens every second of your life, completely beneath your awareness. Your eyes only capture fragments of information, tiny, erratic electrical signals that represent a fraction of the world's actual detail. Your brain takes these incomplete signals and constructs a model. What you see is never the world itself. It is the brain's best guess of what the world looks like. Your brain operates in total darkness, encased in bone. It has no direct access to light or sound, only the constant stream of electrical impulses arriving through the nerves. This chart highlights the physical problem of perception. Light and sound take time to reach your sensors, and those sensors take time to send signals to the brain. Because of this processing gap, your perception of an event occurs a fraction of a second after the event actually happened. Technically, you are experiencing a delayed broadcast. Your conscious mind is perpetually lagging behind objective reality. To bridge this gap, your brain acts as a predictive engine. It anticipates the world by guessing what is about to happen before the sensory data fully arrives, allowing you to react to a threat before you've even consciously processed it. It stitches these delayed fragments and rapid predictions into a seamless, high-definition movie. This simulation is so effective that we mistake the internal movie for the external world. We see the raw power of this world-building machinery every single night. While you sleep, your brain is almost entirely disconnected from external senses, yet it still generates convincing virtual realities with depth, sound, physics, and complex emotions. Waking life uses this same internal rendering process. The primary difference is that during the day, the brain uses incoming sensory data to constrain and correct the hallucination, keeping it tethered to the physical world. This raises a fundamental question about our daily experience. Since the brain can create convincing universes while we sleep, we have to consider how much of our waking world is an internally generated interface. This internal construction includes your core identity. The feeling that a stable you is sitting behind your eyes observing the world is itself a simulated model. Neuroscience shows that the self emerges from the interaction of separate systems. Memory, body awareness, and emotion all pulse together to project the sensation of a singular observer. When these systems are disrupted by neurological damage, the model can fail. Patients may lose ownership of their limbs or experience a complete breakdown in their sense of being a person. A physical universe exists outside our skulls, but processing every raw detail of objective reality is computationally slow and energy expensive. For a species defined by its ability to react, evolution favored a streamlined interface, one that prioritizes quick, useful guesses over absolute accuracy. Understanding the brain as a world-building machine highlights the sheer sophistication of our biological hardware. Inside a dark, silent skull, a 3-pound organ translates raw electricity into the colors, sounds, and meanings that define your life. We are active participants in our own reality, continuously rendering the only